This is Unit 5, Lesson 5, Solving Equations by Factoring. This is a lead-in to doing imaginary or complex numbers with factoring. So we need to be real comfortable with the Algebra 1 information with solving equations by factoring before we go much further. And then we're going to combine this with the radicals that we learned earlier in the chapter. And hopefully we'll come up with something new, a new way to solve some problems that we haven't been able to solve before. With this one, anytime you have a trinomial set equal to something, or anytime you have an equation to a power other than 1, you have to solve that equation most likely by factoring. With this one, the power or the highest power of this expression is x squared. And that power in your equation will tell you how many solutions you should have to your equation. Now sometimes it's an x squared and your solution might be the same number twice, but still you have 2 solutions. So whatever the degree is in the polynomial that you're solving for, that's going to be how many roots or solutions you will have. And in Algebra 1 you learned that the solutions of a quadratic equation like this are called roots, x-intercepts, and solutions. As long as you know what the root number is, you know how many solutions you're looking for. And so we're going to put a lot of things together like synthetic division and factoring together to come up with the answer to those polynomial equations. So just a quick review of Algebra 1. Anytime we're trying to solve a quadratic equation, the first thing we have to do is we have to make sure that equation is set equal to 0. If it's not set equal to 0, we are not allowed to factor it until it is. Then to solve that function, we will factor. So in this one, I'm looking for factors of 12 that add to give me 7. Well, we know from earlier this year, factors of 12 that add to give me 7 are 3 and 4. So I'm going to have an x in each set of parentheses, a 3 in one of them, a 4 in the other. That plus tells me these signs are the same as what that is. So they are both minus. So we've got x minus 3 times x minus 4 equals 0. Then to finish solving this equation, I have to set each of these factors equal to 0. So I'm going to set x minus 3 equal to 0, x minus 4 equal to 0, and that will give me the 2 roots of x equals 3 and x equals 4. And basically what that means is these are the places where this quadratic equation would cross the x-axis. We know that it is a positive a, so it's going to go up, and it will cross the x-axis at 3 and 4. Later, we'll learn how to find the vertex or the turning point or the maximum or minimum of that quadratic equation. But for now, we're just learning how to solve them. In the next one, notice this one is not set equal to 0 yet. So a common mistake is kids try to look at this and say, what factors of 18 add to give you 11, but you can't do that. You cannot factor this until it is equal to 0. So that's going to be your first step. Get that 8 on the other side. So if I subtract that to the other side, I have x squared minus 11x plus 10 equals 0. Now that it's set equal to 0, I'm allowed to factor. So factors of 10 that add to give you 11, that would be 10 and 1. So I'm going to use 10 and 1. The plus tells me these are the same sign and they're the same as that. Then I set each of those factors equal to 0. So x minus 10 equals 0 gives me x equals 10. X minus 1 equals 0 gives me x equals 1. And we've solved that equation. Those are your 2 roots or your 2 solutions or your 2 zeros to that quadratic equation. Here are 2 more quadratic equations in this one. Notice the 8x is on the other side. It has to be equal to 0 in order to solve this. So I'm going to move that 8x over here with the 36x. So that will give me 3x squared plus 36 minus 8. 36x minus 8x is 28x. And then I have the plus 49. And that equals 0. Next, I'm going to factor this thing. Well, notice my coefficient of the x squared term is not a 1 anymore, so this makes it a little more difficult. First thing I'm going to do is check, is there anything that will divide out of each of those terms? The answer is no in this case. So I need to do 3 times 49, that is 147, and I'm looking for factors of 147 that add to give me 28. Well, I know that the factors of 3 are just 3 and 1, so I'm going to use a 3x and an x. And then I'm looking for factors of 147 that will add to give me 28. And those factors are 7 and 21. If you need to use a calculator to find those, that's fine. So 7 and 21 are the factors I'm looking for. So my outside term and my inside terms both need to be 7 and 21. So 3 times what will give me the 21? Hopefully you're saying 7. And 1 times what will give me the 7 that I need? Well, that's 7. 7 times 7 is 49, so I know I've got my numbers right. This plus tells me these are the same sign and they're both plus because that's what the middle term is. And then we're going to set each of these equal to 0 and solve. So 3x is equal to -7 and x equals -7. So this x is -7/3 and this x is -7. Those are our two roots for this quadratic equation. In the next one, again, it's not set equal to 0 yet. When I set it equal to 0, I want to make sure that my x² term is positive so that it's easier to factor. If it's a negative, I would have to factor out that negative first. So I always move it to the side where the x² term would be positive. So if I'm looking at this, the 8x² and the minus are -2x². If I move the 8x over there, it's going to be a -10. So I'm going to move the -2x² over to the 8x². So 8x² plus 2x² is 10x². I'm going to move everything then to this side because remember it has to be equal to 0 before we're allowed to factor it. So -12x minus 14x is -26x, and then I'm going to move the 12 to the other side, so that's a plus 12, and that equals 0. Then, if anything will factor out of the whole thing, that will make it easier to factor. So I notice that all of these are even numbers. So that means a 2 will come out of that. So that's a 5x² minus 13x plus 6. And since my 2 came out, when I factor, that actually is going to drop out because basically I can take that 2 and I can divide it over to both sides. So when you have a whole number that factors out, that whole number is going to cancel out and just not do anything with your factors. It's not going to affect anything at all. So when I do that, I cancel out the 2's here. 0 divided by 2 is equal to 0. So now I have something a little simpler to factor. 5x² minus 13x plus 6. Then to factor this, I do 5 times 6. I'm looking for factors of 30 that will add to give me 13. Well, I know that 10 and 3 add to give me 13. Some of you might have thought, oh, 15 and 2. Well, 15 and 2 won't work because you're trying to add the two numbers to get 13. 15 and 2 subtract to get 13. So we would need to use 10 and 3. So if I do my two sets of parentheses, I know the factors of 5 are 5x and x. And then 5 times what gives me 10? Well, that would be 2. And 1 times what gives me the 3? That would be 3. The plus tells me these are the same sign. They're both minus, and they're both equal to 0. And then I simplify, or set each of these equal to 0 to solve. So 5x equals 3. X equals 2. So here x equals 3/5, and x equals 2 are the two roots of this equation. And the last example for this section, if I have something that looks like this, it still has a variable squared. So the highest power of the variable is still how many factors I should have. If I have something other than just x, if it's x to a power or a variable to a power, I still have to get it equal to 0 before I'm allowed to solve it. So even though this one doesn't have 3 terms, it only has 2, you can still factor to get the answer. So I'm still going to get it equal to 0. 5m² minus 10m equals 0. And now I can factor this. If you look at what you got, this has a 5 and this has a 5. They can both have a 5 come out. And hopefully you notice that has m² and that has m. They both have an m that also comes out. So when I take out the greatest common factor, I'm left with an m minus 2. And I have two factors. I have 5m times m minus 2. I'm going to set each of these factors equal to 0. 5m equals 0 and m minus 2 equals 0. So when I solve those, I divide by 5, I get m equals 0. When I add the 2, I get m equals 2. So my two factors here are 0 and 2. That means that if this were a graph, it would cross the x-axis at 0 and at 2. Now, this probably isn't a graph because it's m, not x. If it was x, then we would be more likely to have a graph that we could associate with that.